All right, so when it comes to factoring the trinomials, last time we were focusing on a strategy where we used a t-table and we looked to see what was the product, right? What were the factors for the constant that could also add up to be the middle term, okay? Now, the reason why today's factoring is a little more complex is because now the leading term is no longer a one, right? A lot of times in that uh, first set of notes that we looked at, the leading coefficient was almost always a one. And so it was very easy to just focus on the factors of the last term and then have them add up to be the middle term. And we knew right away, like, okay, the middle term, the first term is probably just like x times x. We didn't have to think about it. But now we're always going to have a leading coefficient that is not one. All right. So it takes a different set of strategies in order to come up with the correct factors for this polynomial. All right, so here's what we do instead, or at least this is one of the strategies that we can use instead. What I like to do is now we begin by focusing on the ends of the polynomial. All right, so I'm going to focus on the 2. Right, how is it that we can get 2x squared, and how is it that we can get 3? All right, so if I look at 2x squared, I think, okay, what are some possibilities for us to just get 2? Right, what are the factors for us to get 2? Well, the only possible options really is just 1 times 2. Right, that's the only way. Okay. And then I have to look at the last term and think, okay, well, what are some factors for 3? What are the only ways I can get 3? And then if you think about it closely, well, that's a positive 3. So we would need positive 1 times positive 3. Right? Those are really the only acceptable possible factors for those two. Okay. So now we're going to jump into trying to factor this. All right. This is what kind of is considered the guess and test method, right? You kind of make predictions. Here are the possibilities. Now let me try to arrange it in a way where it's going to then give me back the original polynomial that I'm trying to factor. So if I begin by saying, okay, if the only way that we're going to be able to get 2x squared is by multiplying 1 times 2, then I'm going to use 1x and 2x, right? And I'm using them in red on purpose, right? You see how 1x and 2x on the first FOIL, right? If I were to start foiling on the first FOIL, that's going to give me 2x squared, right? So that's why I put them in those positions. And then I also have to focus on how can I get those factors to multiply to be 3, right? Well, I have two options. I could either use positive 1 and positive 3, okay? But I kind of just randomly put them in there, okay? Now, what is the goal? The goal is that eventually when we check for the middle term, that the middle term adds up to be 7, all right? And so this is where we use that kind of double happy face method that we used in the first set of notes. And so right now I just put in a 1 and a 3 because I know that those two, they multiply to be 3. But ultimately I know I did it right if the middle term ends up being 7x. So if I test it, I'm going to get 1 times 2x, so that's 2x. I'm going to get 1 times 3x, and that's 3x. And if I add up those middle terms, I end up with 5x. So I didn't achieve the goal of factoring correctly because this middle term, 5x, does not match the 7x that I'm looking for. Okay. So then is there something that I could do differently, maybe that could get us to having a 7x as the middle term? Any ideas? Yeah, maybe we can switch them, right? Switch the 3 and the 1, right? The position will matter a lot more this time than it did before. So if we do this, all right, well, we already tried this option and it didn't quite work, right? So let's try a second option. I'm still going to use 1x times 2x, but this time I'm going to use 1x, and then in the first factor, I'm going to use plus 3, and in the second factor, I'm going to use plus 1. Okay, so you see my factors are still 3 and 1 to get 3. My factors are still 1 and 2 to get 2. But the arrangement was different because the goal is that we get 7x as the middle term. So now if we test 3 times 2x, that's 6x. 1 times 1x, That's 1x. So when you add the middle terms together, we arrive at 7x, which is the middle term that we were looking for, 7x. Okay, which tells us that, okay, this is not the correct factorization because the correct factorization is actually over here. So we would need 1x plus 3 times 2x plus 1. That would be the correct factorization for number 1. Okay, so this is one of those methods, one of the strategies is to focus on my leading term and find out what are those factors, right, that can get me 2. And then I look at the last term, positive 3. And I also have to think, okay, what are the factors that could give me positive 3? And then it just becomes kind of like a game where you have to adjust them and put them in the right spots so that eventually you arrive at the original polynomial that you started with. Okay. And so you might ask, like, why do I only test the middle terms? Well, I only test the middle terms because I know that in the foiling process, 1x and 2x, that's what gets me the 2x squared. 3 times 1, that's where I get positive 3. Everything else will be one of those middle terms that I have to combine and I have to add together. Okay, so that's why I'm also using the color coding to kind of show like how is it that I'm arriving at that 2x squared and how I'm getting that positive 3, right? The red and the green. So then all we have to test for is make sure that we get these terms to add up to be 7x as well. Okay. All right, so that's example number 1 using kind of the traditional method, all right? I'm gonna show you another method in example 2. It's called the Xbox method, all right? It's a different example, but the numbers are very similar. All right, there's only one slight change here is that we're gonna have negative 7x, right, instead, in the middle. Okay, so here's how Xbox method works, all right? You literally start by creating an X, okay? You draw a big X. All right, so here's what you're gonna do first, okay? At the top of the X, right? So you have this kind of X drawn out at the top. What you're gonna take is you're gonna take the product of the first term with the last term. Okay, the product of those two terms. Okay, so you have 2x squared times 3. You multiply those together. And so you're going to get 6x squared. Then you're going to drop that middle term, the negative 7x. And you're going to drop it here where I have the little plus symbol. Okay, negative 7x. All right. So now from here, you're thinking, what terms can I multiply to give me 6x squared, but add up to be negative 7x? What can I multiply to be positive 6x squared, but add up to be negative 7x? Yeah, I would want to use negative 6x and negative 1x. Because if I multiply negative 6 times negative 1x, I get positive 6x squared. But if I simply add them, negative 6 plus negative 1x, I would get negative 7x. Okay, so those are the two terms that I have found. All right, now what are we going to do with those terms? Okay, this will also, it's called Xbox method. So we've done the X component. Now we need to go do the box component. So the box is just kind of a standard 2x2 box. And you're going to create 4 squares out of it. The two terms that you just found, the negative 6x and the negative 1x, those two terms are going to be on the diagonal of the box. So you could use negative 6x here and negative 1x, or you could flip them, right? Put negative 1x and negative 6x. It doesn't matter, right? But the two terms that you just found, those are going to go on the diagonal of the box. Okay. And you might be wondering, okay, what are we going to use in the first box? And what are we going to use in that last box, right? The top left, and then what are we going to use in the bottom right? We're going to reuse these terms. 2x squared, leading term, goes into the box. 2x squared. Positive 3 goes into the box as well. So you have a positive 3 here. Okay. So we've created the box, and what we're going to do now is we're going to look to factor across the row and across the column, looking for a GCF. All right, so we're going to look for a GCF across the first row. So if I look across that first row, 2x squared minus 6x, what's the GCF of those two terms? Right here, these two terms. What's the GCF? 2 is part of it. What else do they both have in common? Yeah, 2x. Okay. Now, it's not negative 2x that they have in common, because the leading term is a 2, right? The leading term is that first 2x squared. So since that's a positive 2, I don't want to factor out a negative. Okay, there's no need to. Okay, now looking down at the bottom column, or the bottom row, negative 1x and 3. All right. What is the GCF between those two terms? And this time, negative 1x is your leading term. So what is it that can be factored out of both of these? Yeah, we would have minus 1, right? Minus 1 is the GCF between the two terms on the bottom row. Okay. So what you have done by doing so, by factoring out the 2x on the first row and the minus 1 on the second row, is that you have found one of the factors. So one of the factors is 2x minus 1. Okay. Now we have to do the same thing, but now we're going to look on the column. We're going to look at them vertically. So if I look vertically, I have 2x squared, I have minus 1x. What is it that they both have in common that could be factored out? If I'm looking just at the column, the first column. Once again, you're only looking to see, is the leading term a negative? If the leading term is not a negative, then you don't want to factor out a negative. My leading term right now is a positive 2. So I don't need to factor out a negative in that situation. But they do both share x, right? They both have x in common, so I'm going to factor out x. All right. And now the second column, negative 6x and positive 3. What do they both have in common this time? Yeah, look at my leading term. That's a negative 6, right? The leading term is negative 6. So in that case, I do want to factor out a negative, and the number that divides both 3 and 6 is minus 3. So what did we just find? Well, if you look at that top, x minus 3, that's your second factor. So this polynomial factors into 2x minus 1 times x minus 3. All right. So the Xbox method can seem really complex and long at first, right? And so some of you might be thinking like, I don't like this because it seems like a lot of steps, and the other one, it was a little bit more simplified breakdown. Just give it a chance, right? Try it a couple more times. And then sometimes the Xbox method can actually be very useful, very helpful, especially when the numbers start to get really big. It helps us because in other situations, the traditional method, the guess and test, sometimes you have too many options. You might get numbers like 12, where the possible factors are like 1 and 12, 2 and 6, 3 and 4, right? You have so many options to go through that you get you get fatigued of just guessing and testing. And this is where the Xbox method helps narrow your focus a little bit more. All right, so just give it a chance, even though, it might seem a little confusing at first. We're going to try it a couple more times. Question about when we put the negative 6x and the negative 1x in the square, does it matter which side we put them in? No, as long as they're on the diagonal. They have to be on the diagonal, these two diagonals here. This box and this box. Okay. The first box on the top left is reserved for the leading term. You see the negative 2x squared, that one must go in the top left. And the constant term, I'm going to highlight it in purple. It must go in the bottom right. Okay, so that is where those two terms must go. All right, good question. Any other questions here about this second example? All right, let's try number 3. All right, so with number 3, I'm gonna try doing both methods on this one. Okay, so my first method, my original method, is to do what? To take a look at 5 and identify what are the possible factors what numbers can multiply to be 5. And the only options would be 1 and 5, right? That's it. Now, if I take a look at the last term, positive 2, I need the numbers to be multiplying to be positive 2, but the ultimate goal is that middle terms need to add up to be a negative 7, right? I don't have a plus plus situation here. I have a positive 2 product that ends up being positive, but the terms have to add up to be a negative 7. So what do you think the factors ought to be for this positive 2? If I only use positive factors, I'm not going to be able to add up to be a negative 7. So in this situation, looking ahead, previewing, looking at the signs, I can tell that my product will have to be positive, but the sum of the terms have to add up to be negative. That means that I should probably utilize negative 2 and negative 1 as my factors. Otherwise, I'm going to have some issues. I'm never going to be able to get to negative 7 if I only ever have positive factors. So this is one of those times where the cheat sheet that I gave you, box number 1 of notes number 23, that's where this comes in handy. Okay. So let's go ahead and try to factor it using kind of like a guess and test method. All right. I have 1 times 5. Those have to be my first terms. So I'm just going to use 1x and 5x, right? That's the only way that I'm going to be able to get 5x squared. All right. And now I kind of want to think ahead here. What combination, where should I put the negative 2? Where should I put the negative 1? So that when I do check for those middle terms, I will be able to arrive at negative 7. Okay, should I put negative 2 in the first term or should I put negative 2 in the second term? What do you think? Okay, so negative 2 in the second term, okay, which means then that negative 1 has to fit in the first term. All right, so let's test it out. Let's see if this is going to give us the opposite, the minus 7 that we're looking for. So negative 1 times 5x, that's negative 5x. Positive 1x times negative 2, negative 2x. When we add the terms together, negative 5 plus negative 2, we get negative 7x. And that checks out, right? That's exactly what we were looking for. So this looks like this is the correct factorization, right? This is the correct factorization. Let's try it now using Xbox method, right? We know what the correct factor should be. Let's try it out. Let's see if we can get there using the second method, right? This is also for extra practice so that we get used to the Xbox method. So Xbox method is you're going to do a product at the top. You're going to look for a sum at the bottom. What is it that you're taking the product of? Well, you want them to multiply to be the product of the first term and the last term, 5x squared and positive 2. So you have 10x squared as your leading term. I'm sorry, as the term at the top of the x. And what does it need to add up to? It needs to add up to be your middle term. Okay, it needs to add up to be the negative 7x. So what two factors could multiply to be 10x squared, but also add up to be negative 7x? Yeah, there you go, right? It would be a negative 5x and then negative 2x. Okay, so now we can then draw our box. What two terms are we going to use? You're going to use the negative 5x and then negative 2x, okay? Doesn't matter where they go. The 10x squared comes from a product of the first term and the last term, the leading term and the constant. That's just part of the Xbox strategy. Okay, so we're going to use negative 5x, negative 2x in the box. So I'm going to drop negative 5x here, negative 2x in here. Does anybody remember what the leading term or that first box is supposed to have? What does the first box have? What's the term that goes in there? It's 5x squared, right? You reuse the leading term, 5x squared. And then what goes in the last box, bottom right? Yeah, the positive 2. Okay, so we reuse terms from the original polynomial. So we're going to plug in that 2 here. Okay, so now we need to use a GCF about 4 times, right? Row 1, row 2, column 1, column 2, right? So we're applying GCF about 4 different times. So looking at the first row, 5x squared minus 5x, what is the leading term, or I'm sorry, what is the greatest common factor that both of those terms have? Yeah, they can both be divided by 5, and they also both have x in common, so we can divide both of them by x. So our GCF is 5x. What about the bottom 2 terms, negative 2x and positive 2? What can they both be divided by? Yeah, and why is it that we want to use a negative 2 this time? Why do we divide by a negative? Why do we factor a negative out? Right? It's because we have a leading term that is negative, so you want to factor out the negative so that it won't be negative. Okay. So because we have a negative 2x, that's my leading term, we factored out a negative, so the GCF is negative 2. Okay, now look down the column, 5x squared minus 2x. What is the leading, or I'm sorry, the common factor between those two terms? Yeah, it's just x, right? There's no number besides 1 that divides 5 and 2. So there's really no greatest common factor besides 1, but they do share x, so we can factor out x. And then finally, what is it that we have in common here between negative 5x and 2? Yeah, there's really no number that can divide both of them except for 1. And since the leading term is a negative 5, that means we factor out a negative. So we factor out negative 1. So one of my factors would be 5x minus 2. The other factor would be x minus 1. And if you compare, we have the same set of factors that we got when we did the first method, right? The guess and test method. We end up with the same factors. Notice how the order is flipped around. 5x minus 2, right? It's in a different spot, but it's still the same product and it's commutative property. So we don't really care, that x minus 1 is first or that 5x minus 2 is the first term. We can swap the full term around and then it's still the same correct factorization. Okay. So there it is. Any questions so far? How many of you guys like, let's call it method one. Method one is kind of guess and test, list your factors up on the top. How many of you guys prefer method two? Yeah, the full Xbox strategy. All right, so type a number into the chat. Do you like number one, method one, or do you like method two? Okay, we have a lot of ones. Yes.